Hi dear student friends, myself Manjunatha PC, working as Senior Assistant Professor in the Department of Computer Science and Engineering, Reva Institute of Technology and Management, Yelahanka, Bangalore. In continuation to with my previous sessions, I would like to take you on functions, arrays and strings. So before we continue, so let us know what we discussed in the previous session. So in the last session we have seen programs on strings. We have seen what exactly the strings are and how to write the programs on it, and basically we have seen a program to compute the length of a string, program to compute or print a string in reverse, and also we have seen the program to compare the two strings, how to compare the two strings based on the ASCII character differences. So we say whether a string 1 is greater than the string 2 or lesser than the string 2, so or is it equal to the string 2 or not. We have seen a program related to that in the previous session, and also we have seen some of the character handling library functions that are supported in a C library, and we have seen some of the programs related to that also, and we also have seen one of the lab exercise, that is reading a sentence and printing the frequency of vowels and total count of consonants in a sentence. So we have seen how to read a sentence and then how to count the frequency of vowels and the consonants in the particular given sentence. We have seen that in the previous session. So in this session we will be learning the two-dimensional array of characters, which is also called as sometimes the array of strings. So under this we see a look into a pointers. First, before we understand the concept of two-dimensional array of strings, we must understand the concept of pointers. We will see what exactly the pointers are, and then we see arrays and pointers, the relation that exists between the pointers and arrays. So we see there, and then we see some of the pointer arithmetic operations which are possible over the pointers, and then we will see the pointers and the strings, and then we see a program to read the list of names, and finally we see here the string handling library functions. Similar to the character handling library functions, the C also provides certain library functions for handling the strings exclusively, and we will see that particular library functions, and we see a simple program wherein we will be using a string library function. And then we will see one of the lab exercise program, that is a program to search a name in a list of names using a binary search technique. So first, the two-dimensional array of characters or an array of strings. So before we proceed with the concept of two-dimensional array of characters or the array of strings, so we must know what exactly the pointers are. Now, every computer stores the data in a memory location. So every memory location will be having its own unique address, whatever the data we are processing in the system. So every data will be stored in the memory location, and every memory location will be having a unique address. And in the programming, the identifiers are the one using which we identify the memory locations. So that is, identifiers are the name given to these memory locations. So consider and one declaration here: int x is equal to 25, y is equal to 167. So x is a name given for some memory location where I will be storing 25, and similarly y is a name given to some memory location where I will be storing 167. So int specifies how much amount of memory is required for storing the integer element. Similarly, the char specify how many bytes of memory is required for storing the character variable. Basically, integer will take 2 bytes in case of 16-bit machine, and character will take 1 byte in every machine. So here A is an array of characters. So here I have 4 characters A, B, C, D, and this is an array of size 5, because here the one null character also will be stored in the memory. So A is an array of 5 character elements. Now if you link into the memory organization, memory how exactly it is stored, the location name what we are giving in the program may be X and Y, and similarly A of 0, A of 1, A of 2, A of 3, A of 4, and this is the content of the memory, that is the value which is stored in the memory. The X value I am assigning it 25, that might have stored in the memory the value 25. Similarly for Y it is 167, and for A of 0 it is A of 1 it is B, A of 2 it is C, A of 3 it is D, and finally A of 4 it is not there, but the string basically is a array of characters terminated by a null character. So the last character will be null character, and we can note that here the address is associated with every memory location. So X is an integer type of data, so it requires 2 bytes of memory, and here the starting byte of this particular X will be like 1400 here. So this is the starting 1400 and 1401 are the 2 bytes, so which will be allocated for the variable X. Basically the memory addresses are byte addressed, like every byte will be having a location and address value. So here 1400 is the location of 1 byte, 1401 is the next consecutive byte, and together these 2 bytes is the memory allocated for the variable x there. And similarly y is also a variable of type integer, and it requires again the 2 bytes of memory area, and this memory area is 7600. See, it is not continuous memory area because it is not an array, they are the normal variables. Only in case of arrays we have the continuous memory area or continuous memory allocations. So maybe like for the value y, the address starts at 7600 and its next immediate byte will be 7601. Those are the 2 bytes allocated for the variable y, and the contents are 167 for y and 25 is for x. Similarly for character array, so a is holding the base address of the array. If I am assuming the address starts at 1650, then you can see like the immediate consecutive elements of the memory, so or the array elements will be stored in a continuous memory location. 1650 is the value corresponding to the 0th element, 1651 is first element, 1652 is for the a of 2, and similarly 1653 is for a of 3. So each character will take 1 byte of memory allocation, so it is in continuous manner like this. And in case if it is an integer array, then it could be like 1650 is the starting address of the 0th element, next 1652 will be the starting address of the second element, and so on, because each element will take 2 bytes of memory area. So this is how the memory contents and the memory addresses we can look into. So here we can see like, so in the previous case, so here x is 25 and y is 167, and now if I alter the value of x to 22 and y to 14, now what happens is the x value will get the value 22 and y will get the value as the 14 there. So what we can note here is like altering the value of a variable changes the content of the memory location. So here I am altering the value of x. So altering the value of x means what? It goes to the exact memory where exact it is stored, and the content will be overwritten there. Earlier it might be 25, now it has been changed to 22. Here it was 25 there, and now after overwriting that, so means getting the new value there, the older data is overwritten there. And here also earlier it was 167, now it got overwritten to the value 14 there. Now, so these particular addresses what is there, we can store in the programming. So for in some certain situations we require these particular addresses using which we perform various operations, and the only way by which we can store these addresses is by means of using the pointers. So we will see that a pointer is a variable which can hold the address of another variable. So pointers are the normal variable kind of structure, so which will take the address of another variable. These are the only one which can hold the addresses of another variable. Explicitly we cannot assign any value to the pointers, they can hold only the addresses of another variable, preferably of same type. It should be of same type, it cannot be of dissimilar type. We will see in certain cases examples how exactly it is used. The declaration of the syntax, declaration syntax of declaring a pointer is like we have to specify the data type followed by a star and then the name of a pointer here. Fine, we have to specify the pointer name. Pointer name can be any identifier names, or how we name the variables or the array names. So same way we can have any name for the pointer names also, and the data type is the any kind of any data type. It can be basic data type, or it can be derived data type, or it can be of any kind. So like int, float, char, all these are the basic data types, and we can use even the derived data type also, which is not in the scope of your syllabus, but we may use even the derived data type also. And here we can see like the symbol star. This star is called as a dereferencing operator. This is not the multiplication. Multiplication is the one which we have seen in the arithmetic operations, but basically this star refers to a dereferencing operator. So now, so consider these particular declarations. Int x is equal to 25. X is a variable of type integer, and I have declared int star ptr. Ptr is a pointer to an integer. When it is a pointer to an integer, it can hold only the address of some integer variable only. So since x is an integer variable, a pointer can hold the address of x. Now, so here star is a dereferencing operator, and ampersand is called as the address of operator. Even we use this ampersand even for bitwise ANDing also, but in this context ampersand and star, which are dereferencing and address of operators, are the unary operators. They work only on the one operand. Fine. So next, so here we will see that the x is the value of x is 25. Assume that x has given a memory location at 1400. So I am assuming that this address could be anything else, something else also when you run when you execute the program. But I am assuming here like x is located in the memory address 1400. Fine. So and then so pointer is holding the address of x. Ptr is a variable which is holding the address of x. See that it is not a normal variable, rather it is a pointer variable. Since it is holding the address of x, the content of ptr is 1400, which is is the address of x. Since PTR itself is a variable, that is also getting stored in some memory location, and that location where exactly pointers are stored is so the pointers is stored in this context, it is a 7600. Fine. Never, pointers will never be negative or floating point number. The pointers are always the whole numbers, right? So here, so x is the address of x is 1400, whereas address of PTR is 7600, but the value of PTR is 1400, which is the address of x. And using these pointers, we can have a indirect accessing of the variables. We will see that in the few statements. And we note here, pointer is a variable storing an address. It is storing the address here. It is not storing the actual value of x, rather it is storing the address there. So pointer is not storing the actual value of x. We are not storing the actual value of x, rather we are storing the address of x. So where star PTR is equal to ampersand of x, with this we are assigning the address to the PTR, which is a pointer to an integer. Now, so look at this particular program here. I have declared int x is equal to 167, x is a variable of type integer, and I declare a pointer, so px, which is a pointer to an x, where x is an integer variable there. So the value of x is the 167 will be printed there, because the value of x what I am assigning here is 167. Px is equal to ampersand of x. With this statement, px will get the address of x when I execute the program. So based on the address of x, where exactly the x will be getting stored, so the px will get the respect to the address there. The address of x is %u. So here we should use %u, because always the addresses are whole numbers. They will never be a negative or a floating point number. So %u could be the format specifier for printing the addresses, because they are very long numbers, large numbers. So if we use %d, we may get the negative the data in the output, because the integer may exceed that is normally when it is a signed number, so we may have the negative numbers as well as the positive numbers. MSP is used for checking whether a number is a signed number or an unsigned number, so whether it is a negative number or a positive number. But when I am using here pointers, always the pointers are whole numbers, we never get the negative numbers there, so we must use here %u. The %u refers to a printing of an unsigned decimal number here. If I use %d, then that is for the signed number. So since I am supposed to use the unsigned number here, printing the unsigned number, I am using here %u. So %u px is holding the address of x, I am printing the address of x there. The another way of printing the address of x is with the value of ampersand of x. Ampersand of x and px remains same there. The value of px is %u comma px. What exactly the value of px? Which is nothing but the address of x only, because it is holding the address of x. The px, ampersand x and px here, all the three will print the address of x only. Then the value of px is also address of x. Then value at address %u is %d. So means the address of x and x value. So value whichever is stored in the address of x, that is 167 only, that gets printed over there. The other way of printing the same information is px and star px. This is most important. This star is called as dereferencing operator. The meaning of star px is like value at address px. So value at address space, what px is basically holding, it's holding the address of x. Coming to the previous slide here, px is holding 1400. If I say star px here, star PTR means the value at address PTR. If PTR value is 1400 there, then the meaning is like value at address PTR, that value at address 1400. What is the value at address 1425? This is the way how I can indirectly handle the variables using the pointers. Now, so if I have this particular program, the sample output of this particular program will be like the value of x is 167, the address of x is 65,520, some larger value is getting given the memory location where exactly the x is stored, and similarly with the different ways of I am printing the address of the x there. And then the value at address 65,520 is 167. Similarly here the value at address 65,520 is 167. These are the various data which I am printing, so using px and star px, ampersand x and star of ampersand x similarly. And finally I am printing the address of px is %u comma ampersand px. Ampersand px is the address of the pointer variable px. When this could be a different location where exactly the pointer is stored. So in this particular code we can see like output, so address of pointer is 65,524, whereas the address of x is 65,520. Likewise, so we can perform the various ways of printing the addresses of the variables. Now, if you look into this particular declaration here, so as an example, int I is equal to 5, int j is equal to 10. So int I is holding the value 5 and j is holding the value 10. When I go for the next declaration there, so I am declaring a PTR as a pointer to an integer, and here I am not assigned any particular address. So, here I do not have any particular value for this particular pointer variable. It is just a declaration. It says that integer pointer variable, that is it. And if I go to the next particular declaration, so here I have that star star PTR, which means that PPTR is a pointer to a pointer. Fine. So, here int double star is like integer pointer variable. It is a double pointer. We can use any number of times this star star. Only thing is, based on that we have to perform the actual dereferencing when using the in the programming. Now, when I go for the next statement here, so this is PTR is equal to ampersand of I. So, here I am assigning the address of I to the PTR variable. So, now earlier the PTR I not assigned any address there. Now, once after this particular declaration statement, PTR is equal to ampersand of I. So, the PTR will get the address of the I. So, there could be any value, so larger value, that will get the address of the I variable will be assigned to the PTR variable, which is a pointer variable. Now, when I go to the next statement here, PPTR is equal to ampersand of PTR. So, PPTR will be holding the address of a PTR. So, PPTR is double pointer, it can hold the address of one pointer only, and when I use PTR, it is a single pointer which can hold the address of another variable of preferably the same type. It is an integer pointer, so it is holding the address of integer here, and it is a pointer to pointer to an int. So, here PPTR is holding the address of PTR. So, now the PPTR is pointing to PTR, which in turn is holding the address of I. So, now we can see like here the PPTR value is address of PTR and PTR value is address of I, and in the address of I can find the value of 5 there. Next, so when I use star PTR is equal to 3. So, the main meaning of star PTR is like the value at address PTR. So, what is the value of PTR? So, PTR value is address of I. So, here when I use PTR is equal to 3, the previous value of I was 5. You can see like previous value of I was 5. Now, it has been changed with the new statement star PTR is equal to 3. When I do this operation here, star PTR means value at address PTR. PTR value is address of I. So, it means like value at address of I, it was 5 earlier. Now, it is overwritten with a 3 value, and hence, so here we can see like the value of I got changed as a 3 over there. Next, when I go for the next statement star PPTR is equal to 7, indirectly, so via the PPTR I am altering the value of I to 7 now. So, PPTR is pointing to PTR, PTR is pointing to I. So, with this what happens is the 7 will be updated in the variable I there. So, next when I go for the next statement, PTR is equal to ampersand of j. So, when I use this operation, now the PTR is pointing to the address of j, not the address of I. So, because of this particular address what I am assigning to PTR, now PTR is pointing to the address of j. But here the PPTR value remains the same. PPTR is holding what? The address of PTR, and hence indirectly PPTR is also now pointing to the j only. The value of PPTR is not changed there, only the value of PTR is changed. So, because of which the PPTR value remains the same, still the pointer to pointer is pointing to the PTR only. This double pointer is pointing to the PTR only there. Now, so when I do now, the star PTR is equal to 9 now. So, now it is indirectly pointing to the j value, and here the j value got the changed there. Earlier the value of j was 10, and now the value of j has become 9. So, this is the way how exactly we can perform certain operations using the pointers. But basically, when you are using the pointers, you must be very careful, and sometimes they are very dangerous also. And only thing is, so using the pointers in certain situations, we can perform various operations which cannot be done without the concept of pointers. So, in these particular situations, we must and should use the concept of pointers. Now, so when you perform certain operations, so we can over the pointers we can perform even the arithmetic operations also. So, here for a particular pointer, if I add a value 1, it means like I am going to the next memory location. If I subtract a value from a pointer, it means that I go for the previous memory location. So, here what exactly the pointer into 2, multiplication of pointer and the division of pointers. We cannot perform any multiplication or division over the addresses or over the content of the pointer. The only two operation which we can perform over the pointers is either an addition or a subtraction. So, these are the only two valid pointer arithmetic operations we perform in the programming. Say for example, here when if PTR is an integer pointer variable, and if I am adding 1, then the PTR value will be incremented by 2, because so PTR is pointing to the integer type, means integer will take 2 bytes of memory area, and hence it will go for the next memory location by adding 2 bytes. Similarly, if PTR is a pointer to a float, and if the float is storing a 4 bytes of memory area, then adding 1 to the address is nothing but adding 4 bytes of memory area. So, the entire PTR value will be incremented by 4. Similarly, it is applicable even for the decrementation also. We will see in some examples how exactly it will happen. Now, so consider this particular declaration of an array. So, here A is an array of 5 integer elements where the elements are 12, 34, 56, 78 and 22. So, altogether we have 5 elements there, and now so in the memory we can see like the A of 0 is the name of the 0th element and its value is 12 and its address is something 1400. Similarly, A of 1, A of 2 up to A of 4, and you can see like 1400 and 1401 are the 2 bytes associated with A of 0, 0th element, and 1402 is the base address of the second element, right, A of 1. So, is here the another byte is not shown, only the starting address of each memory location is shown here. The base address of the 0th element is 1400, for the value 34 it is 1402, similarly for A of 2 it is 1404, and for A of 3 it is 1406, and for A of 4 it is 1408. So, here 1408 and 1409 together forms the 2 bytes of memory which is allocated for A of 4. Similarly, we can see like each element is taking 2 bytes of memory area. So, 5 integer elements will be getting over there 10 bytes of memory area getting allocated there. So, you can see like 1400 to 1409 means the 10 bytes of memory area is getting allocated there. So, here so A of 0, the ampersand of A of 0 is nothing but 1400. So, we can see like so A is equal to ampersand A is equal to ampersand A of 0, all these three mean the same. So, that is the A is holding the base address of the array 1400 and ampersand A also mean the base address of the array 1400, and similarly it is same as ampersand of A of 0. And also what we can note here is like A of I, when I use it is same as star of A plus I, which is also same as star of I plus A, which can also be written as I of A. So, that is so here it may not be visible there properly. So, here if I have a statement A of I, this is the syntax basically using which what exactly we do is we access the ith element in an array. So, this is same as so value at address so A plus I, where A is the base address of the array and we will be adding I to it. Now, similarly this is same as so I can write it as just an addition, I can write even like this also, which is also same as I of A. Fine. So, this and this both mean the same here because of the pointer arithmetic which happens inside. So, the value of A of I and I of A both remains same there. Now, so look at this particular situation here. Now, A of 0 means star of A of 0. So, means what is the value of A here? The base address of the array is 1400. Value at address 1400 plus 0. If you add anything 0 to any value, it remains the 0 the same value. So, here star of 1400 means the value at address 1400 is 12. So, basically A of 0 means we access the element 12 only. Now, A of 1 means star of A plus 1, which means that star of 1400 plus 1. And here you have to see like I am adding 1 to the address 1400, but here we are storing the addresses of an integer variables here. Each integer will take 2 bytes of memory area. So, adding 1 to it means like 2 into 1, 2 bytes I am going to add to it. So, this means like the new value what I get after this addition is like 1402. So, value at 1402, that is star of 1402 is value at 1402. So, what is the value at 1402? It is a 34, it is nothing but A of 1. Similarly, if I go for A of 2 there, the star of A plus 2 means star of 1400 plus 2. So, again here since we are dealing with the integer pointers here, so here the adding 2 to it means like so 2 into 2. So, adding 4 bytes to this particular address 1400. So, here we get value at address 1404. So, what is the value at address 1404? It is nothing but the value 56, which is same as A of 2 only. Similarly, A of 3 means star of A plus 3, which is nothing but star of 1400 plus 3, and here this 3 gets multiplied with 2 because integer will take 2 bytes of memory area. In case if it is a float, then this 3 will get multiplied by a 4 because each floating point data will take 4 bytes of memory area, and in case if it is a character array, then here the 3 will multiply by 1 because each element will take 1 byte of memory area. So, by then what will happen here in the where A is an array of integer is, so this 3 gets multiplied by 2, so we get 1406. The value at 1406 what we get is 78 there. So, this is how. So, A of 0 is same as so star of A plus 0. Similarly, in general we can say like A of I will be same as star of A plus A. This I can also write it as star of I plus A, meaning wise it remains the same, and which in turn can be written as I of A. Now, Consider this particular program where we read array elements using the pointers. So here 5 is an array of A is an array of 5 integer elements. The 5 elements I am going to read here, I is equal to 0, I less than 5, I plus plus. Here I am not using ampersand A of I, rather I am using A plus I only. Here I am not mentioning so A of I, square bracket I am not mentioning, I am just using here A plus I. So you can note here like, so when I use A of I as this particular equation, A of I as star of A plus I, so then I can use A plus I without the star. With the star means value at address A plus I. So since scanf will expect the address here, I just use here A plus I. So A plus I will be accessing it will point to the ith address in the array A. Fine. So ith element, address of the ith element in the array A is the memory location pointed by A plus I. And if you want to fetch the element from that location, then we have to mention star of A plus I. So here we can just mention like, so here in the scanf statement A plus I, that's it, which is same as ampersand of A of I only. Now the 5 elements are, if you want to print back the elements on the screen, I is equal to 0, I less than 5, I plus plus, print of percentage D, star of A plus I can mention here. Star of A plus I is nothing but A of I there. Fine. So this is the way how exactly I can make use of the pointers there. Now, so consider a 2-dimensional array of integer elements here. So here A of 0 0, A of 0 1, A of 1 0, A of 1 1, A of 2 0, A of 2 1. Here we have 3 rows and 2 columns. So this is 0th row, first row and the second row. And here we can see like A of 0 will hold the address of the 0th 1-dimensional array, A of 1 will hold the address of the first 1-dimensional array, and A of 2 will hold the address of the second 1-dimensional array. So that is, this is the 1400 is the address of the 0th 1-dimensional array, 1404 is the address of the first 1-dimensional array, and 1408 is the address of the second 1-dimensional array. This is 3 arrays of 1-dimensional arrays here. So is the reason we have the 2-dimensional arrays here, 3 rows and 2 columns. Each row correspond to 1-dimensional array there. And here whenever I use A of ij, it is same as star of A plus I plus j here. So now, so here what I mean here is, so with respect to the A of 1-dimensional array, I may use the statement like this: A of I is same as star of A plus I. But when it is a 2-dimensional array, if it is something like B of ij, then this is same as, so value at address star of B plus I then plus j. Fine. This will take us to the exact location to the particular ith row, and in the ith row with this I go for the jth column, and from that location I will be accessing the value there. So this is the way how exactly I can use the pointer in accessing the elements of a 2-dimensional array. So here I will be going to a particular row, and here I will be going to the particular element there. Now say for example here I have a 2-dimensional array. Say for example if it is B of 0 0, and somewhere here something like this is 0 0 0 1 1 0 1 1 2 0, and we have another element there 2 1. So altogether we have, this is one row, this is another row, this is third row. We have 3 rows there. Now say for example I want to access the second row element and the second row first column element. Second row first column means second row, this is the element if I want to access. Then how exactly I will be accessing? So here we normally do like B of 2i, so sorry 2 1. B of 2 1 means we will be going to this particular location. So here what exactly we do is star of B plus I value is 2 plus the j value is 1 there. Now, so B means if the starting address of this particular location is something like assume 600, then here this will be the value for 602, and this will be the value 604, and this will be the value 606, and this is the value 608, and this particular element will be the address is 610. So here I have 1 2 3 4 5 6 element. So 600 to 611 means 12 bytes of memory will be allocated over there. Now we will see here, so what exactly the meaning of this particular statement is. Star of B plus 2. B value is what here? So the base address is 600 plus 2 plus 1. So what exactly the meaning of 600 plus 2? It is an integer data what I am considering here. So each element will get 2 bytes of memory area. 2 into 2 is 4. So this is same as, so value at address 604 plus 1. And again, so 2 to the 4 here, so 4 will be added to this, and plus 1. So again here So value at address, so second row and the first column. So here I is equal to 2 and j is equal to 1. So 600 will get added to the 2 here, but basically what happens here is, see, when I am adding 2 here, so each a of 0, each row is having two elements there. So it is not that 2 get multiplied with 2, rather 2 will get multiplied with 4, because in each array, in each one dimensional array, I will be having two elements. Each elements will take 2 bytes of memory area. So here the b of 0 will take 4 bytes of memory area, b of 1 will take 4 bytes of memory area, again b of 2 will take 4 bytes of memory area, because each row is having two elements. Each element will take 2 bytes. Obviously b of 0 will take 4 bytes, b of 1 will take 4 bytes, b of 2 also will take 4 bytes. So here the 2 will get multiplied with 4, not with 2 here. So here 608, and in the particular location 608 is the starting address for the second row. So when I is equal to 2 here, this is the second row basically, and this is the first row, and this is the 0th row. When I is equal to 2, exactly with this will be coming for the second row, and in that plus 1 means what? Each element will take 2 bytes of memory area. So this is same as value at address 610. So when I go for the value at address 610, I will be accessing to this particular element only. So this is the way how exactly the pointers will be dealt with the 2-dimensional arrays. Whenever I am using the arrays, it means that we will be using the pointers only. Fine. So this is very easy to write instead of this. So is the reason. So most of the programmers will prefer writing this particular way instead of this. But this is also useful in certain situations when we are passing arrays as parameter to the functions. We will see in some of the programs in the later part. So now, so here, so we can see like a of ij, we can write it as star of a plus I plus j over there. So next, consider this particular program here, int a of 3 2. So a is an array of 2-dimensional array of elements having 3 rows and 2 columns over there. So ptr is equal to a of 0. Ptr will hold the base address of the 0th array, and you can see like it is a pointer to pointer, because here 2-dimensional arrays are array of 1-dimensional array. I am trying to hold the address of these particular arrays. So I am using here double pointer, not a single pointer, because 2-dimensional arrays are arrays of the 1-dimensional arrays. Now star ptr is a declaration here, it is a double pointer there, and ptr is equal to a of 0. When I use this, we may get the warning as suspicious pointer conversion. The reason is like, so when I am using the arrays, so arrays are implicitly treated as a constant pointers whose address we cannot change. So here I am trying to assign that particular address into a normal pointer variable which is not declared as a constant here. So we may get here a warning as suspicious pointer conversion, but still we can allow to execute the program. So ptr is holding the address of the 0th row here, right, and here each row will be having 2 elements over there, right. So each row is having 2 elements, means each element will be taking 2 bytes of memory area, and hence here each row will be having 4 bytes of memory location. Each row corresponds to the 4 bytes of memory location. So here I is equal to 0, I less than 3, I plus plus, j is equal to 0, j less than 2, j plus plus. Here the star of pointer plus j. So the star ptr is base address of the 0th row here, currently it is holding, plus j means each element of the 0th row it will take. After taking each elements of the 0th row, ptr plus plus, when I do ptr plus plus, ptr will be incremented by 4 bytes, because ptr is holding the base address of the 0th row. Each row will be having 2 elements, each element will take 2 bytes, so altogether 4 elements will be taken by each particular row. So this will be incremented by 4 bytes, whereas here when I add j here, so this will be added as, so incremented by 2 times the j value, because each element will take 2 bytes. So star ptr plus j means it will be incremented by, so star ptr plus 2 into j value, because each element will take 2 bytes in this particular way. So here I am accessing the I am specifying the address of particular element in the jth row. Fine. So in the particular ith row, I am particular element in the jth column I am specifying here the address, and where exactly to that particular location I will be reading the value from the keyboard whatever we enter. And similarly when I go for printing the elements back on the screen, so I am reassigning ptr is equal to a, because we have incremented the ptr value. Again ptr is holding the base address of the array, and I is equal to 0, I less than 3, j is equal to 0, j less than 2 here. So we write the statement as star ptr plus j, this complete whole star here. So this is dereferencing operator. Using this ptr we are trying to access the particular row and particular column element. Ptr is holding 0th row. When I is equal to 0, ptr will be holding the 0th row. When I is equal to 1, so the PTR will get incremented here, PTR will be pointing to the first row. Again when I is equal to 2, PTR will be get incremented, PTR will be pointing to the second row, and so on. In the particular row, the jth column it will be pointing to by addition of this particular j here. So star PTR plus j, this whole star means we will be accessing the element in the respect to row and respect to column. Fine. So this will give the normal printing of the matrices elements there. Now, so when you come to the strings here, S of 5 is edusat is one particular string what I have taken, and here star PTR is the syntax what we use here to declare a character pointer. PTR is a variable of type a pointer to a char, right. So here character is a data type what I am using, and here the pointer variable is star PTR. When I use PTR is equal to S here, the starting address of S will be assigned to the PTR variable. So here some of the memory contents we can visualize as, so S of 0 is the 0th location is E, then D, U, S, A, T. The characters are given the memory locations because it is a character array. In a continuous memory location we get 1400, 1401 and so on, and finally a null character also will be assigned for S of 6. So here, so the size of this particular array is 6. So here it has to be like it has to be 6 is the it should not be 5 here, it is supposed to be a 6 here. Now, and then PTR is given the address of S. So PTR is holding the address of S. What is the address of S here? Starting address 1400. So PTR will get the value as 1400. PTR is also a character variable, so means pointer variable which will get allocated in some other memory location. I am assuming here like the address of PTR is 6240, and the value what it is holding is the base address of the array, so S, which is an array of characters. So here 1400 is the base address of this array S, and that will be holding in the pointer variable PTR. PTR is a pointer to char here. Now we can see like PTR is equal to S is equal to ampersand S here. So which are all holding the same value 1400 in this context. Now here to read a string, scanf percentage S we can use, or ampersand S we can use, or we can use a PTR. So all mean the same thing, and also for printing we can use here S or ampersand S or PTR we can use. All are so performing the same operation. Though it is S and ampersand S and PTR, the value what they hold is address of, that is 1400 in this context. So they all print the same data required there. Now, so consider a program where I will be reading a string and printing it on the screen. Now using the pointer here. So see, str1 is a pointer to char, str2 is an array of 50 characters, and ptr is a pointer to character. So here we clear the screen using clr str function, enter a string. So here we are reading str1. So str1 is a pointer to char here. I have not mentioned here size of the character, but here since it is a pointer to a char, it will hold the address, and from that particular address whatever it gets, so it will read the characters, so that all will be stored in the memory location here, right. So whatever we enter from the keyboard, for how many letters we enter, based on that the size of the str1 will be calculated there. Now enter a string 2. str2 is an array of 50 characters here. So the moment we enter there, we can read the characters into the memory location pointed by str2. Here whether I use str2 or ampersand str2, both mean the same there. Then I assign, so ptr is equal to str1. So I will be assigning the str1 to the ptr, means the address of str1 I am assigning to the ptr there. When I do that, the string is percentage s comma ptr. So I am printing the string via the another pointer variable called ptr. And then what I do is ptr is equal to str2. str2 address of the str2 I am assigning to the same ptr. I am overwriting the ptr. In this context, ptr pointer is pointing to str string 1, whereas now after assignment of the string 2 to the pointer, so now pointer is pointing to the next string, that is a string 2 there. The memory addresses will be different there. Now the string is percentage s comma ptr. Again it will print the new string 2 here. In the first we will print string 1 via the pointer, and now we will print the string 2 via the pointer there. Now, so consider the two-dimensional array of characters here, so s of 350 here. So we have here, so the three strings, so edusat, program, Bangalore. Now here, so each row is correspond to one particular a string. So each row is again here a one-dimension array here. So s of 0 is edusat, s of 1 is program, and s of 2 is so Bangalore there. So now, so in this particular case, s of 0 is the address 1400. If I assume s of 1 will be 1450, because each row size, so each row is having number of columns is equal to 50, what I mentioned here, what I declared here. So each row will be having the 50 elements, and so here 50 bytes will be allocated. from 1450 bytes means we get 1449 as the last byte. So now the next row will take the 1450 as the address location. From there again 50 bytes will be allocated for the second row, and finally 1499 will be the last byte of the second row, and again from 1500 the starting byte of the starting address of the third row will start from this particular location here. So here again PTR I am declaring as a pointer to char, and I am assigning PTR is equal to the address of S, I am assigning to the PTR there. So now, so S of 0 address of the 0th string, S of 1 is address of the first string, and similarly S of 2 is address of the second string. So we can see here like 2-dimensional array of characters are a 1-dimensional array of strings. So this using this particular 2-dimensional array of characters we can perform operations very easily in programming. Say for example, so this is a program for reading the list of names. So here names of 1050. So 10 rows I have, 50 columns I have. So it means that I can read the 10 names here. Each row correspond to the, so having 50 columns there. Each row correspond to one particular name or a string, and I am restricting like the number of characters that can be present in a name or the string that I enter could be a maximum of 49 only, because so one will be reserved for the null character, right. So here, so names of 10 50. So 10 is the rows and 50 is the column there. So but anyhow, before I start reading the names, we must ask the user to enter the number of names. So here we ask enter the number of names, scanf %d %n. So then after reading the n number of names, enter n names. We are displaying that message. Then here for I is equal to 0, I less than I plus plus, enter name I plus 1 here. We print here I plus 1, and I is equal to 0, we will be printing enter name 1. When I is equal to 2, we print enter name 3, and so on, because as per the user from the program point of view, when I is equal to 0, 0th element will be accessing, but from the program from the end user point of view, so I is equal to 0 doesn't mean to him, so he mean like the first element means the first element of the array. It is not the 0th element as per the programming. So is the reason this is for the display purpose we will be using here I plus 1 there, but I value is not altered there, we just added 1 to the I index. Then here with this we will be printing the name, we will be reading the name of the string whatever the user enters there, the element to the value names of I. So when I is equal to 0, we will read names of 0. When I is equal to 1, we read names of 1, and so on. Names of 0 will provide the address of the 0th row. Names of 1 will provide the address of first row. Names of 2 will provide the address of second row, and so on up to n minus 1. We read all the names there. Again, we print the names back on the screen. The %d names are. So based on the n value, we display that message, and then we will be printing that again using the same construct names of I. We are using basically the addresses here. Name of I will hold the address of the ith row in this particular 2-dimensional array of characters what we have declared there. Basically these are the pointers which are holding the addresses of the 0th row, first row, and so on based on the index value whatever we mentioned there. Now this is the way how exactly we can read a particular n names, and we can display that back on the screen. With this particular program we may use in the binary search program, which is your lab exercise program. So to read the n value, n names, and then we have to search for a particular name, so using a binary search method. Now, so string handling library functions, the way we have seen the character handling library functions, similarly we can have functions over the strings also. Certain library functions do available in the C library, so which will support for handling only the strings here. Now, so the string handling functions includes the functions to perform the useful test and manipulation of the strings. These particular functions used to perform only the operations on the strings, and we we may perform certain test also over this using this particular string handling function, and we may use some other manipulating programs also, operations also over the strings, something like string concatenation, or it can be like finding a substring, or something like finding a comparison of the strings, and so on. Now each function receive a pointer to a character as an argument. So here when you are handling the string functions, they always take the parameter as a pointer to char, and sometimes they may take even integer also. Now, so these particular library functions exist in a header called string.h. That this particular header files we must include when we are using the string handling library functions. Now, so the commonly used string handling library functions are unsigned int string length. So this is a function which will return the length of the string. See here. Here the parameter what we are passing as const char star, because the content of this particular string should not be altered. So is the reason we say like it must be pointer to const char as the parameter. The return type of this strlen is a integer. It will return the length of the string. If you say strcpy, so this will copy the string from source string to the destination string. It will copy from source to the destination. If you see the example, you will get to know that how exactly it happens. Now string cat, this is for the concatenation operation. So characters, the source string will be put at the end of the destination string, so that we will be having the concatenation of the strings over there. Then similarly we have strcmp, the comparison of the two strings, the destination string and the source string, two strings will be given there, and the two strings will be compared, so based on the ASCII character difference. Fine. So here next is strchr. Strchr is we look for a particular character in the string. So in the string, yes, we will be looking for a particular character. Similarly, we have str. So here we are looking for a particular character in the string, whereas here we look for a particular substring in a string. So m underscore str is the main string and s underscore str is the substring. We look for a substring in this particular main string, whether it is existing or not. And similarly, we can reverse the string using strrev operation, right? So these are certain operations, so certain string handling library functions using which we can perform various operations. And we can note that the return types are character star, pointer to character only. After copying the string, where exactly it is copied, that base address will be returned by the strcpy. Similarly, after concatenation, where exactly the concatenation has happened, the base address of that will be returned by the strcat function, and so on. So here, so we always, most of the string handling library functions will return the value as a char star, which is a pointer to char, whereas here stringlen you can see like it is returning a integer type, because it is returning the length of the string, so it is returning the integer type of data there. Now one simple program I will see where exactly we use the string handling library functions. When you are using the string handling library functions, we must use here string.h header file. So here I am declaring a dest as a destination, an array of a character of 25 characters, and str1 is pointer to char, which is holding the string called edusat. str2 is another character pointer to char, which is holding a string called a program there. Now, so I am using another character pointer, which is a blank, star blank, which is holding a single space there to leave the space between the two words or two strings. Now I am using even another integer variable called length. Now string copy destination comma str1. So I am copying the string str1 to the destination. str1 is edusat, I am copying that to the destination. So dest is the array of 25 characters there. Then strcat destination comma blank. I am concatenating the blank with the destination content. What exactly the destination is having now? Edusat it is holding. So after edusat I am leaving one space over there with this string cat. In the first string cat. In the second string cat, what I do now is string cat destination comma str2. Now after leaving the space there, so after the edusat leaving one space, I may write the program there. So concatenating the string program. At the end of the edusat, I may be writing the program there. At the end of destination, I will be writing the content of str2 there. So now the complete string in the destination will be like edusat program. Then length is equal to string len of destination. So complete characters which is present in a string edusat space program, so will be the length of the string. So what len will get via the strlen function. To make use of all these particular function, we must make use here the string.h header file there. Then the length of the string, so percentage s is percentage d destination comma length. So here, since I am printing the double quote, I am writing in printing the double quotes there, so I must use the escape sequence there. So I should write slash double quotes here, because you should not give the meaning for the double quote, so we must use here a slash symbol there. The length of the string percentages within the slash is percentage d, that will be the display what we get there. Now basically in this particular program what we get is, so the output of this particular code will be like the length of a string edusat space program is something like a 15. So probably here 1 2 3 4 5 6, 1 space 7, then 8 9 10 11 12 13 14. So possibly the 14. So 14 is the length of the string what we get finally. The destination string will be edusat space program, and length of this will be 14. That will be the common output of this particular program. Now, we have some 8th lab program here. So, which is to develop, implement and execute a C program to search a name in a list of names using binary searching technique. So, here we are supposed to take the list of names and we have to perform the binary search technique there. So, now we have to search for a particular string, so particular name in a list of names. We know that when you are using the binary search, the list must be an ordered list. The list must be in increasing order or it could be in a decreasing order. So, only then we can perform the operation of a binary search. Now, in binary search, what exactly we do is we take the lower index and the higher index and we take the middle value and we take the key value, and if the key value is greater than the middle value, we go for the right subarray, otherwise we go for the other, we check for whether key is equal to the mid value. If it is equal, we declare that the element is present, and in case if the key value is lesser than the middle value, go for the left array. That is the way how exactly we do. With respect to the array of integer elements, we have seen how exactly binary search technique can be implemented. Now, so when you go for the program, so when you are using the list of names, what are the necessary data required here? So, we have to declare a low, high and mid for with respect to the binary search technique. We have to use the lower index, higher index and the mid value is supposed to compute there, and to read the names of a list of names, you must have an 2-dimensional array. Here names of 10, 10 and 50, 10 rows and 50 columns. The maximum I can read here. So, 10 names here. Then I am using one more array called str, which is an array of 50 characters. This is the key string, which particular name I supposed to search in the list of names. For that, I will be using another variable called str. Fine, it could be like key also. Whatever the programmer interested with, they can give the respective name there. So, n is the number of strings I am reading I can have, and I is the loop iterator. Now, in this, the next what is supposed to use is, so we have to write the statements for reading the names. Enter the number of names. I will be reading the names here, and then enter %d names comma n. So, I will be mentioning here how many names I am supposed to read. Then for I is equal to 0, I less than and I plus plus, then we have to read each element. Enter name 1, enter name 2 is the display message, and then f flush stdn. This I will be using here because I am using the function called getS. So, here when I use the getS function, here I can read a names having the space in between, having the surname and the middle name and all that, the first name, middle name and the surname. So, we will be having a space between the names. So, when we have the space there, the scanf will not work. So, because of that, I must make use of the getS function, and when I am using the getS function, I must do f flushes stdin, because in the input buffer there could be some characters that must be flushed. So, before we read the character getS. So, here f flush stdin will read the name. After flushing the string, means stdin, I read the name. When I is equal to 0, we read 0th name. When I is equal to 1, we read first name. When I is equal to 2, we read second name, and so on. So, here we will be reading all the n names entered by the user. Now, after that, so printf enter the name to be searched. We have to read the key element, name of the key, so which is to be searched. So, here again we have to f flush stdin, then getS str. It is recommended that whenever you use the getS or getS functions, you must use a flush stdin. Now, after that, we will be reading here the the name to be searched in the list of names. Now, after that, we have to perform the binary search operation. How low is equal to 0, high is equal to n minus 1. So, while low less than or equal to high, so what I do here is, after having the index here, I do here mid is equal to low plus high by 2. I compute the middle value, then I compare here string compare str comma name of mid. So, this is exactly the middle name present in the list, and then this is the key element which I am going to compare. We know that when you do the comparison, it returns a 0 if the strings are equal, and it returns a negative value if the first string is less than the second string, and it returns the positive value if first string is greater than the second string. If it is equal to 0, it means that both are same. So, what we print here is name found at position %d comma mid plus 1 get ch exit 0. I will be exiting, I will be terminating the execution in case if the name which I am searching is found. Now, else if string compare str comma names of found mid is greater than 0 means the str value is greater than the names value. Names of mid means what? The string is greater than the names, so the middle name. So, I have to go for the right array. When I go for the right array, so low need to be modified. So, low is equal to mid plus 1. Else means what? Obviously, str is lesser than the name which is at the middle location. So, here, so I should go for the left array. When I am going for the left array, high should be assigned as mid minus 1. So, this will be keep repeatedly happening here. So, until the low is less than or equal to high. So, or the key element is found. So, when I come out of the loop, the low will exceed the high value. In that context, name does not exist. So, because if I have names the name which I am searching is found, then obviously we display a message here, the name found at position so and so, and we exit. If the name is not found, we will be coming out of the loop, and here we display like name does not exist in the list, then get ch return. This is the way how exactly binary search can be used in searching the names. But here make sure that in the list of names what we are providing, they should be in the alphabetical order. So, this is a sample output of this program. Enter the number of names. I am entering 4 here, and they enter 4 names, some randomly, some 4 names are given here, something like Arun Kumar, Bhaskar Reddy, Chandrasekhar and Lahari, and enter the name to be searched. If I am giving the string as Bhaskar Reddy to be searched here, then after successful search I get that name found at position 2. So, at the second position we have this particular the name, the Bhaskar Reddy there. So, here we have to see that the name should be given in alphabetical ordering only. If it is not in the alphabetical order, then binary search will not perform in a right manner. So, here the binary search work only on the sorted list of elements. So, if it is unsorted, then only option is we have to go with the linear search. Anyway, so I will end up this particular session here, and the next session we continue with the concept of functions. Thank you.